Users can create their own custom components. To demonstrate, we're going to create a spin component, which will simply rotate an entity by an amount each update. Firstly, we copy and modify the component template source file, and we modify it to become a spin component source file. As we can see, this inherits from component. Components in this program can be thought of as simple structs. They prefer plain, publicly accessible data with a minimal number of methods. We'll see why this is in a minute. Following this idea, our spin component just needs a float value representing how much to rotate the entity by each update in degrees. For components to work in the editor, they must support binary file I/O, also known as serialization and deserialization. These methods are provided for us, and we just need to fill in the blanks. In serialize, we write the component details to the binary file. In deserialize, we read them back in and populate the component fields. Wrappers for more complex data types such as rectangle, color, and vector2 are also provided. Now that we've made a spin component, let's add it to an entity. If we open the program and go to add component, we can see that our spin component is now an option. If we add and view, we can see our rotation amount variable has shown up in the editor. Currently our component doesn't do anything because it has no methods. Rather than add methods to component themselves, the program uses what are called systems. A system is essentially a single function performed on a number of entities once per update. Which entities the system operates on is determined by which components they have. We're going to make a spin system. It will operate on any entity with a spin component, and its function will be to rotate the entity. The process for this is similar to components. To begin, we copy and modify the system template source file to a spin system source file. As we can see, this inherits from entity system. A system is a simple class containing only a single process method representing the system's function. Before we write the process method, we need to call the base entity system constructor to specify which entities the system operates on. This just takes an array of type. The system will operate on entities with a spin component. Since rotation is stored in the spatial component, entities in this system will also need to have one of those. Now let's write the process method. We start by fetching the components the system needs to operate on using the generic getComponent method. Every entity has a spatial component, so easy access is made possible. Once we fetch the components, we just need to modify the rotation by the rotation amount in degrees. The last thing we need to do is tell the program to actually use our system. We do this by subscribing it to the program inside the user setup init method. ECS core stands for Entity Component System, the three core parts of the runtime object model in the program. If we run the program now, create an entity with a spin component, and play the scene, we can see that our entity rotates. If we pause, change the rotation amount value, and then play again, the entity now spins much slower.